Welcome to 204B objective number 3. We're going to look at the construction of a relay and the three main parts. A relay is a pretty simple device and it doesn't take very much to build one. First, we need to have a core. Within that core, we need to have a coil, and the core actually comes in two pieces. One is a stationary piece and the other one is a moving piece that is connected to the armature. The armature is also what is responsible for moving the contacts either open and closed or closed and open, depending on the status of the contacts. Okay guys, I'm going to break down these two different types of relays so we can see what the insides look like. First of all, nameplates. All the information on the top here is all for these contacts. Now this is a 4-pole contactor. So the information here being 25 amps and 600 volts maximum, that's how much ampacity and how much voltage I can have between these 2 points. So this is my input and this is my output on my contactor. And I can handle up to 4 different circuits on here. When I rotate it this way, these 2 pins down here actually go to my coil, and we can also see that there's a label here stating what my coil voltage is. This is a 120 volt coil. You'll notice there's no ampacity on here because it draws such a low ampacity, it doesn't really matter to us. This one here, once again, same thing. We have a nameplate value here. This is a 3-pole contactor. I have lines 1, 2, and 3. We have my voltage and my ampacity here. So this is only good for 40 amps. And I can go 120 or 110 volts, 50 hertz or 60 hertz. And on the side here, this is where I have my coil terminals. So this is where my coil is. We can take off these screws and we can see just on the inside here. Take out these lids. Now I can see the actual contacts. So we can see we have 4 normally open contacts here, and you can see that everything is sprung in there. On this one here, I have 3 normally open contacts. At the very top here, you can see right inside here, these are the springs for the actual contacts. So when these pull in, those springs take out any extra bounce that might happen, and they keep firm connection between the 2 contacts, the bottom and the top one. The ones that are moving, these are on the armature. So this is my armature here, and this is my armature here. So the armature is the part that moves. This particular unit is kind of nice. I can just squeeze the bottom here, and I pop this out. And on the inside, I have my core, and I have my coil, and then I have the other part of my core, which is also on that armature, and you can see that moving. So this is a stationary part of my core, and you can see my shading coil on here as well. And you can also see the shading coil on this part of the core. So these 2 cores, this one being stationary, would attract the other side, and that is how that is moving that armature. This is my coil. Nothing more than just a wrapper wire. On the inside of the coil, of course, it looks like it's an air core, but as soon as I put this in there, we can see that it is a steel core inside my coil. And here's my terminals that we saw on the outside of it earlier. So I energize these 2, create the magnetic field around this. The magnetic field is transferred to my core, and this core will attract this half. So that's how this works. In order to reassemble this, you normally have to pay attention to how you disassembled it. We want to put the coil back in place again. Make sure it is completely set in there, no gapping or anything else. And then you want to put the rest of the core in. You'll notice that the shading pole is on this side. I'm going to have the shading pole on the opposite side. It won't fit in any other way, so it has to go that way. So each side has a part of the shading coil. And then I just take my base here and I clip this back in. And we're done. For this one here, it's slightly different. I have to unscrew the base plate here, so we'll take this apart quickly. Now on the inside here, I remove this piece. This is part of my core. I remove this piece. This is my coil. This is my armature spring here. We did not see the armature spring on this one, but it is in place. And then I have the other half of my coil, my core there. And of course, you can see that core moving when I activate the armature. So this is connected to the armature. This spring has to be made in such a way that it will not overcome the magnetic force, but it'll open up the terminals as quickly as possible. And once again, my shading poles should be on opposite sides. So when I put these two core pieces back together again, I want them to go like that so that they are on opposite sides. And again, my terminals here, we found them on the side. That is for my coil. And my coil will go above there again. Just got to slide that back on here again, like that. Push it down, make sure it's fully down. Take my core, place it back in there again, and now I've reassembled this. So the internals on these look very familiar to each other. There's not a whole lot of difference. When I look at the terminals on here, I see that this is a 4-pole, single throw. So this is a 4-pole contactor typically used in lighting, whereas this one is a 3-pole contactor. I can use this for motor controls or air conditioners or whatever else the case is. Lots of different things I can use that for. When I look at this, I see that I have L1, L2, L3, T1, T2, T3. So these are related, and these are related. So when this comes back on top of here, I can see where my input, my output here is, input and output here is, and input and output here is, and coil is down there. So this is where I connect my control circuit, and these are all for my power circuits. In contrast to the NEMAs, we have the IEC design. We can't take these apart. These are not built to come apart. These NEMAs are built to come apart because they're serviceable. If I have a burnt out coil, I can replace the coil on here. I can take apart the terminals here. I can replace any of the contacts. I can do whatever I want with these. These are great for being serviceable units. These typically have a lower cost than the NEMAs do, so therefore it's easier and cheaper just to replace these rather than have to service them. So we cannot open these up without destroying them. One thing that we'll notice is that we do have numbering differences here where we have still L1, L2, L3, L1, L2, L3. By the way, this is a reversing starter. These are two starters that are linked together with a mechanical interlock here so that I cannot push down on both the armatures at the same time. And they have this bridge here, and they have this bridge here to automatically change the wiring from forward to reversing. And we'll talk a bit more about that when we get to that part of the course. This one here, I have A1 and A2 going to my coil. So this is where I would connect my control circuit. On here and here, these two are called auxiliary contacts. So when the armature here gets pressed down, not only does it close my power contacts in here that are L1, L2, and L3, but it also activates these two. This particular unit has a normally open here and a normally closed there. So I have one normally open, one normally closed auxiliary contacts. And depending on what you order from the manufacturer, you can order this with any number of auxiliary contacts in any particular order that you want. You do not have to have one normally open and one normally closed. That's just how this one is. Down here, this is the overload, and the overload is used for motor control circuits. This overload can also work with this kind of starter. All we have to do is take it off of here, put it onto there, and it screws directly onto the T1, T2, and T3 terminals inside the unit itself. So that is the difference between my NEMA and my IEC starters, and that is a look at the internal parts to what the contactors and relays have inside them. You've now reached the end of 204B Part 3, so make sure you review the different parts and pieces of the relay or contactor and how they all associate with each other, and make sure you understand its construction. Then return to Blackboard and continue on with 204B Part 4.